Hello folks, welcome to our last animatronic sound and motion video. And in this video we're going to show you how to make a talking brain using either push buttons or a remote control or both. For this video we're going to have several upgrades that we're going to do in terms of hardware, and we're going to actually pull in a couple of extra pieces of hardware and a little bit of extra software. Now the first piece of hardware we're going to replace is this battery supply that we originally used for our SSC32U. We find that when we use a 50-foot Cat6 cable, it's just really underpowered, and the batteries have a tendency to get weaker as you go on, so we need a constant source of power. So we actually went to one of these little power sources. Now this is a 5-volt, 3-amp power source. This was great if we were using just one skull, but when we start to use multiple skulls, it also gets a little bit underpowered, because you have to remember this is only 3 amps and each servo pulls about a half an amp. So this is only going to power 6 servos. And if we take something like a more complicated setup, like the Eric skull that has eyes that light up and blink and rotate and move, we have 6 servos with this alone, so we're going to run out of power before we go to anything else. So, let's get this out of the way and show what our actual final solution was. Now, you can see on this board that this board has actually 6 transmitters that can go to 6 separate receivers. Each one will control 4 servos. So that's 24 total servos. Now we won't be using them all at once, but we might be using quite a few at one time. So what we did was we went to a bigger power source. And that's this power source right here. Now this is also 5 volts, but it's 40 amps. Now, you might say, oh, is that too many amps for a single servo? You don't have to worry about that, because it's only going to draw the number of amps it needs. The SSC32U is not going to draw more amps than what it can use, so you're not going to burn it out. So don't worry about your amperage. Your volts are fine. It'll pull whatever amperage it needs for whichever servos it wants to power. Now, if we turn this around and we take a close look at this, you can see that we have 3 wires here. This is actually just a computer cable. Just a standard cable you plug into your 120. This is one end. We cut the other end off. That gives us a live, a neutral, and a ground. The live is the black, goes into the part that says L. The white is the neutral, the ground is the green. This will allow us to provide power to the SSC32U when we hook up our little cables right here. You can see that we have the black to the minus voltage, the red to the positive voltage, and that hooks up exactly the same way on the SSC32U. This hooks up the same way as what our battery powered pack did, except that we're using something with a lot more amperage and something that doesn't run out of power. It doesn't go dead on us. So the first thing you're going to do is download a software called Helmsman Pro, which is from the same people that brought you Monkey Basic. So just type in Lifeape in your browser. Click on Lifeape. It's just lifeape.com. And then go to Shop and VSA Value Added Software. There you'll find both the Monkey Basic Trackskull 2 and the Monkey Basic Helmsman Pro. Helmsman Pro is what you want. You add it to the cart, it will run you about $60. When that's done, just open it up. And you'll see you have this interface here. The great thing about Helmsman is that it allows you to load the VSA routines that you've already made up all into one particular software. So now we're going to hook up our receiver right here with our Cat6 cable, and we're going to connect that to our transmitter right here that's hooked up to our SSC32U. Next, we're going to go into Helmsman. We're going to set our options so that we're using the remote keyboard, which is what the default comes with, and we're just going to hit OK. And we're just going to add a couple of VSA routines. And you see we already have some preset lectures up which had to do with different parts of the brain. So let's just add the first one, the cerebellum. Okay. Now over here is our play, our pause, our stop. This is a loop control which allows you to continually run whatever it is you have. And this is a randomizer. So if I had several pieces of lectures in there, I could put them in any random order and it will just select them on its own. Now here are the trigger events, and I'm going to press that so that I can start it. But now before I do anything else, I'm going to hit this button right here, which is Assign Critical Routines. What this does is it allows me to download a routine to Helmsman, so it's not pulling it from VSA, it's already in Helmsman, so it operates much quicker. It will start this up much faster than it would if you had not touched it, if you had left it in just VSA. So let's add the routine, brain cerebellum, and you see it loading. Now that routine is loaded in Helmsman. So let's just go ahead and play.
Cerebellum, coordination of voluntary movement, balance and equilibrium. Some memory to reflex motor action.
Okay, now it's going to keep playing because we set it to.
Voluntary movement, balance and equilibrium.
So we're going to go ahead and stop it. So let's take a look at this area for triggers right now. And let's go ahead and hit edit. Right now you can see that because we only have the routine brain cerebellum, it's set up for everything. But here we have a list of things that we can do. We can switch on, switch off, toggle, whatever it is we want to do. So let's say I want it to just play once and then stop. Okay? So I'm going to hit play always, then stop. That means if I hit the button to make it start, it will play immediately and it will stop as soon as it's finished. Okay, so now I have the first trigger set, input 1. So if I go ahead and I hit the Alt 1 button,
cerebellum, coordination of voluntary movement.
so my trigger now for input 1 is set. So if I hit the Alt 1 button, that's my trigger, I will trigger it off to start the skull at wherever it is the routine begins at. So I'm going to hit Alt 1 and it begins the routine.
Voluntary movement, balance and equilibrium. Some memory to reflect.
Now let's stop that. But in our case, we don't want to have to set the Alt 1 button. We want to be able to do it remotely. And eventually we just want to have it separate where we don't even have to touch it and somebody can come up and just press a button and start whatever routine they want. So if we're at a convention, whoever is there to look at our booth or whatever it is, they can just hit a button that says cerebellum and get a lecture out of the skull by simply doing that. We don't want them to have to touch our computer. We want to have a separate button that does this. And to do that, we're going to need a couple of other pieces of hardware. We go back to Lifeape and we're going to go under accessories. And this is where we find two really unique accessories that we have. The first is the Gatekeeper. That's this right here, which is really great because it's going to allow us to control those routines remotely. The second is the 4-channel wireless RF module. That module is this right here. It runs $25 and it will allow us to use a remote control to control how Eric speaks. So now we're going to hook up our remote control module, and that hooks up right here on the Gatekeeper. Then we'll hook up our Gatekeeper to the computer using a USB, same type connection that we use for the SSC32U. One end plugs in here to the Gatekeeper. The other end, the USB end, just goes straight into your computer. So now we have our remote set, and our trigger will now be set from our remote. We go back to our Helmsman software. We make sure that we're set on Haunt Monkey Gatekeeper. We make sure that we're set on Haunt Monkey Gatekeeper. We make sure that our communication port is set, and we set it down to Haunt Monkey Gatekeeper input output right here. Once that's done, we hit OK. We make sure our triggers are set. We still have the brain cerebellum. We take our remote.
Cerebellum. Coordination of voluntary movement, balance, and equilibrium. Some memory for reflex motor action.
If I press it again, it stops. Press it again.
Cerebellum.
Starts at the beginning. It does not start where it originally was. It starts back at the beginning. That's something that's important to remember. Now let's go ahead and add another routine. Occipital lobe. And we want to edit those inputs. So right here we have the cerebellum. Here we're going to change this to occipital lobe. Actually, first, before we do that, we're going to set occipital lobe in our critical routines. So let's go ahead and set the critical routines. Add routine, occipital lobe, and now it's set in with our critical routines. So it'll actually come up faster. Once that's done, we go back to our triggers. We edit our triggers. We change this to occipital lobe. And in this case, the behavior is going to be the same. We want to play it always, then stop. Okay? So, let's set that. Now let's start by playing first the cerebellum.
Cerebellum. Coordination of voluntary movement.
Now let's say somebody wants to see the occipital lobe. We simply press 2. Stops the cerebellum.
Occipital lobe.
And we go to the occipital lobe. We want to stop that. We hit 1.
Cerebellum.
And it starts the cerebellum again.
Voluntary movement, balance, and equilibrium. Some memory for reflex motor action.
So now let's say we wanted to do something different. Let's say we want somebody to be able to walk up, and let's say we put a button right here. And we want it to be able to start with the button. Well, we've wired this button so that we can trigger it right here. These are our trigger inputs right here. These are our switches. We want a trigger so that when we press the button, it will start our routine. So if you take a close look at this, you can see the red is going to the 5-volt output. The 5 volts is actually provided by your USB port. The other end goes to whichever trigger it is, and we have 8 of those that we can set up. So this is a little button set up now to our trigger number 1.
Cerebellum. Coordination of voluntary movement, balance, and equilibrium. Some memory for reflex motor action.
Now you can do a combination of these. You can stop that at any point you want. If you set your next input, right here. And we'll just tell it to stop. So now just play the cerebellum.
Coordination and voluntary movement, balance and equilibrium.
And if I want it to stop, I hit the number 3 button on the remote. Because the number 3 button is the one that we just edited to tell it to stop. If we want it to start back up again,
Cerebellum, coordination and voluntary movement, balance and equilibrium.
and stop.
Memory reflex motor action.
Now you might be wondering, okay, why the switch? And that's a very important thing. That's a really good question. Well, the answer is actually found in the Helmsman software itself. But first, look at this button. You can see that we wired a red wire on one side and a black wire on the other. The red wire is going to go into the Gatekeeper's 5-volt output section. That output comes from your USB. The black will actually go to the trigger portion on your Gatekeeper. So let's take a look at Helmsman. If you look at Helmsman and we go to load our triggers and edit them, you get this dialog box that comes up here, and the first thing it says on the right hand side, these triggers are active high, which means that the input pins, input 1, 2, 3, etc., must be connected to 5 volts in order to be activated. 5 volts is provided on the board and should be used. So the trigger is actually activated by this button because one of the lines goes to the 5-volt output and the other line goes to the trigger. And since we have 8 triggers, we can actually hook up 8 buttons. And that brings us to our ultimate goal. Well, if you look at this, you can see we have buttons on each section of the brain, so that whatever button we press will trigger Gatekeeper to start Helmsman to explain to us whichever one of the routines we want it to. So if we have a lecture on this portion of the brain, we press this button, that lecture will start, just like we did earlier. But now we can do it directly from the brain. And we can have Eric explain whatever that lecture is by pressing any one of these buttons. So now we need to show how this was set up on Gatekeeper. Well, each one of these buttons has its wire, just like the button we showed you. In this case, instead of red and black, we have a red and a green line. So each one of these buttons has a positive and a negative lead, which all lead to the bottom of this brain and are encased in this casing right here. So we're going to pull this casing off and show exactly how it was wired. So if you look, we have all the green wires going in one direction, all the red wires going in the other. Now the 5-volt output that we have, the 5 volts coming from our USB, they can all be hooked up to just one wire, and that's what we did. We took this, all these wires leading into one section where we soldered one wire to all of these, because we only need this one 5-volt output coming from the Gatekeeper. Because as you saw in Helmsman, the Gatekeeper requires these triggers to be active high, means the input pins, which are each one of these, has to be connected to a 5-volt output. So this is our 5-volt output, all going into all of the triggers, but only one 5-volt output applied to each and every one. So now if you look close, you see we have our live wire and all of our trigger wires. So if I press this button, which is the button for lecture number 2, my live wire makes a connection with the trigger wire for number 2, and that creates the event and starts the lecture. If I press this button, which would be trigger number 3, I connect the live wire to the wire that goes to trigger 3, and that starts that lecture, and so on and so forth. So each time we press a button, we're simply making a connection between the live wire and the trigger wire associated with that button. So now we've plugged in our power source, we've hooked up the SSC32U so it's working with VSA, we've plugged in our lines that go from the SSC32U over to our skull. Over to our skull. And we've hooked up Helmsman, and we've moved all of our routines over into Helmsman and assigned each one of them as a critical routine. So if you look at Helmsman, you can see that we've loaded the cerebellum, occipital lobe, parietal lobe, and frontal lobe. You can see that we've assigned them all as critical routines. We've started our triggers, we've edited our triggers so that each trigger has a different brain function: cerebellum, occipital lobe, parietal lobe, frontal lobe. Each is set to play always and then stop. So we hit OK. So now we have our brain set up so we can press the button that we want to be able to activate our skull.
Initiation. Problem solving. Judgment. Inhibition behavior.
Parietal lobe. Sense of touch. Differentiation, size, shape, color. Spatial perception. Visual perception. Academic skill. Occipital lobe. Vision. Reading. Perception and recognition of printed words. Cerebellum. Coordination of voluntary movement, balance, and equilibrium. Some memory for reflex motor action.
This is the final result, but before we go, there are a few things we need to go over. First is the base. This is a 7.5 by 1 inch by 12 inch piece of oak. Onto it we glued the stair rail base that we got from Home Depot for about $4 or $5. In addition, we took a 3-foot dowel and we cut it into 4 pieces. We then cut a 1-inch hole with a hole saw through this base and halfway into the oak base. Then we slipped the first dowel into that hole and glued it down. Then we took the other 3 pieces and we glued those to this first dowel and to the base itself, holding it together with rubber bands. Now this is really solid and it's not going to come apart. The last thing we'll do with this is add a coating of stone coat resin to make it look like it's marble. Next we go over to the Gatekeeper. If you look closely at the Gatekeeper, you can see that we moved all of the wires to a different pin. That's because the Gatekeeper only has 8 inputs. And of those 8 inputs, 5 are going to go to the brain. So we moved all of those over by 3 because our remote control will only control 4 inputs. And we have 5 inputs on the brain. So what we're going to do is we're going to use 3 of those inputs for the remote control. The last 5 we're going to use for the brain. And we'll show you exactly why later, but that allows you to add a couple of routines into the lecture so that you can just have some sort of a segue, and it can be humorous or not, that goes into the different routines. The last thing we want to look at is over here at our base where we have our SSC32U and we have the input connection. Now this input connection right here, the live wire, we really want to have a way to shut this on and off because we've got it right now to where we have to unplug it or plug it in to start it. Sometimes that SSC32U needs to be shut off right away because it's putting too much strain on your servo. And you don't want to have to sit here and unplug it and take the risk of a short. So what we did was we took that red wire from our power source, we ran it into this switch. And then to the other end of this toggle switch, we ran the other wire that goes up into our SSC32U. Now, what this does is it allows us, with the simple flip of a switch, to turn that SSC32U on and off rapidly, so we don't run the risk of breaking any of our servos. So now we have all our routines set into Helmsman. The first 3 are actually going to be operated by our remote control. And let's actually set this one to stop. The next 5 are actually going to be our brain functions. We actually didn't do the lecture for the last one, that's why it's not there. So, let's go ahead and say we have somebody passing by our booth. We have our remote control. And we want Eric to talk.
Hey, you, come here. Yeah, you, press the button.
Hit the second routine.
You know you want to. It's just a button. Come on, the hippie won't mind. Parietal lobe. Sense of touch. Differentiation, size, shape, color. Spatial perception. Visual perception. Academic skills.
Okay, Eric.
Whoa! Attack of the Mushroom People. When are you getting that haircut?
I'm going to see a barber this week.
Does the barber have a lawnmower?
No, he doesn't have a lawnmower.
I'll lend him a weed eater.
Say goodnight, Andy.
Good night, Andy.